Here in this video, we're going to look at our relative extrema. And the previous video, we were looking at your extrema or your absolute extrema. And here, with the relative extrema, you're basically looking at kind of your high or low point. And this is looking at the graph as an open interval. And what we're saying is if you look at this peak in this graph here, at this region, we have a peak in the graph where the graph goes up and then comes back down. Well, this point is your relative maximum point. And one way you can think of this is we call this a relative max because, in a sense, relative to this area, that is the maximum value. And this is where your graph is actually changing directions. And also, if you look at the slope of our tangent line, it's going to be a horizontal tangent line with a slope of 0. And based on this, you probably can guess if we go, as our graph continues down to this valley or this low point where our graph changes direction, this point would be a relative minimum point. And at this point, we have a relative minimum, again, because your graph is changing directions, and the horizontal, your tangent line is a horizontal line with a slope of 0. So if we look over here at the other graph, we have a sharp turn here at this point, and again, here your graph is changing directions. So this point, we would have a relative minimum point. So what we can draw from this is that if we have relative extrema, they're only going to occur at our critical numbers. So this is the similar example we looked at before, and if we look at this graph of f of x equals x cubed minus 3x squared, we'll notice that the graph from the left to right, it goes up to the origin here, then it turns and goes back down, and then it curves and goes back up. And we want to identify the relative extrema. And the key word here is relative extrema. And the way that we can do that is identify our critical numbers. So if I take the derivative, we have 3x squared minus 6x. And remember, if we want to find the critical numbers, we set the first derivative equal to 0. So at this point, we could factor out our 3x, and we would have x minus 2. So therefore, 3x is equal to 0, x minus 2 is equal to 0. So x equals 0, and x equals 2. So here we have our critical numbers. Okay, now if we look at the graph at x equals 0 and x equals 2, well, at x equals 0, that's this point here, and it does look like that would be a relative maximum point. And then if we look at x equals 2, when x equals 2, our graph is here, and that would be a relative minimum point. Okay, so you're looking at the graph here again. Relative extrema only occur at critical numbers. Now, one thing to be careful with, that doesn't mean that all critical numbers are relative extrema. So just keep that in mind. But if you have a relative max and a point where you have a relative minimum, those points will be critical numbers. Okay, so your relative extrema only occur at critical numbers. But do not always think of this as the other way around. If you have a critical number, it may not be a relative extrema. And we'll investigate that further in a future video. So for right now, just be aware that if you're identifying relative extrema, you're basically looking at here at your peak or your valley where your graph is actually changing directions. So be very careful with the term. If the directions ask you for extrema, then you're looking for the absolute, particularly on a closed interval. If they're asking for relative extrema, then you're just simply looking for the location here where your graph has either a peak or a valley.